Hello there. Greetings from India. My name is Deepa Venkitesh. I work in the Department of Electrical Engineering in the Indian Institute of Technology, Madras. My institute is located in a city by name Chennai, which is here in the south of India. In fact, we have facing the Bay of Bengal. As you can see, our campus is carved out of a national park, and you can distinctly make out how green it is as compared to the rest of the city. It really gives me great pleasure to represent our country in the Globalization in Photonics R&D meeting, and many thanks to Paul Crump and the organizing team of IEEE Photonics Society, especially Lauren, for enabling this. I really wish to be there to meet all of you in person, but it looks like globalization also has its own constraints, and I'm very positive that we will definitely meet in person sometime in the near future. Let me start by first recalling the giants, the legends from India who have made their mark in the scientific history. I'm just capturing those who have made their mark in the area of optics, photonics, and astrophysics. Starting with Satyen Bose, who contributed to the Bose-Einstein statistics. C.V. Raman, whose Raman effect we all know has far-reaching consequences in communication. J.C. Bose, who's first made the radio receivers supposedly even before Marconi, and who has done a lot of indigenous experiments out of his garage in the domain of what we call today as microwave photonics. Meghnad Saha and S. Chandrasekhar, who have their own names in astrophysics, Saha limit and the Chandrasekhar limit. Kapani, who is known as the father of fiber optics, who made the first fiber endoscope. C.K.N. Patel, who was behind the invention of carbon dioxide laser. And last but not the least here, Paul Raj, who first realized MIMO communication, which we have started using in the domain of optical communication. The list of the legend actually goes on. From the recent times, we know Desh Deshpande, who has made a commercial impact with his Sycamore Networks, which is probably one of the earliest optical networking company, followed by Kumar Shivarajan's company in India, S. Chandrasekhar from Bell Labs, who have made far-reaching contributions towards WDM and coherent communication. In addition to their research, there are certain stalwarts who have made their contribution through not only their research but also in terms of their teaching and in terms of the books that we all follow. Govind Agrawal, Kehar Singh, Joy Ghatak and Tyagarajan, Vishnu Pal, and so on and so forth. I'm sure the list is incomplete, but moving on. So what's the landscape in India? It's quite rich in human resources. We are 1.39 billion people with a median age of 28.4, very, very diverse. We speak 122 languages, of which I think 26 are officially accepted. There are 234 mother tongues, very diverse set of people, and all this young population is being trained by 23 Indian Institutes of Technology, 7 Indian Institute of Science Education and Research, and Indian Institute of Science. And in addition, we have 54 central universities, 411 state universities, 123 deemed universities, 287 private universities. Maybe the list is not complete, but this is the landscape. We do spend a lot of resources in training our human resources. And in addition, we have the niche labs, which are, for instance, the Defense Research Development Organization Lab, the Indian Space Research Organization Labs, the Council of Scientific and Industrial Research Labs, and then there are these specific niche labs such as the Tata Institute of Fundamental Research, the National Center for Biological Sciences, the Raja Ramanna Center for Advanced Technologies, which does a lot of work on lasers in addition to other things. Several labs of Department of Atomic Energy, the Raman Research Institute, which was founded by Sir C.V. Raman, and so on. So how do we capture the work carried out in all these places? So I just divide this landscape to people who do components and devices, subsystems and systems, or networks, or we could say that there are a large class of people carrying out fundamental research, modeling and simulation, experimental realization, industry, taking all these into the industry to the production environment. Especially, I will be focusing on fiber optics and photonics. And in terms of components, where we stand, we have several institutes who are contributing significantly in the area of integrated photonic components. We do have clean room facilities in IISc in Bangalore and in our own institute at IIT Madras. Other research groups, you could say they are pretty nascent, and they are mostly carrying out either design studies or work through collaborations and through the fabless routes. In terms of subsystems and systems, there is a large activity on sensors. These include fiber optic distributed sensors, temperature sensors, perimeter sensing, OTDRs, Brillouin OTDRs, Raman OTDRs, phase OTDRs, and so on. Then there is also a class of sensing which is like air quality monitoring. IIT Gandhinagar is leading in that area. Then there are several institutes of which are pioneering in chemical and biological sensing. In terms of fiber lasers, India is leading in that. Primarily, of course, it started for defense applications, but then there's also a lot of commercial interest because India is one of the biggest places where diamond polishing is the largest industry for diamond polishing is in Surat in Gujarat. So there's a lot of activity in high power fiber lasers, in beam combining of lasers, and there's also indigenous development of dope fibers for fiber lasers. In terms of fundamental research, going into these systems, there is a lot of activity in plasmonic metamaterials in several of these institutes. From the government side, there has been this nano mission and this quantum mission, which has dedicated funding for setting up national facilities for each of these. IIT Madras, for instance, is one of the centers for both nano mission and for the quantum center. And interestingly enough, in the last few years, India is attempting its own gravitational wave observatory, which is getting located in a district called Hingoli in Maharashtra. What about industry presence? This is only very representative for optical communication. We have a very large optical fiber manufacturer, which is Sterlite Technologies, which is in Aurangabad in Maharashtra. Then there is this cluster in Bangalore, which is doing optical systems and networks. Smaller companies which do educational kits and components. CDOT does technology transfer for optical transceivers and components. Wellmoney and Navtech are companies which do free space optical communication, Li-Fi, and so on. And down south in Kerala, we have SFO Technologies, which are specializing in devices, components, and subsystems. I will move on to my own kind of experience. When I joined IIT Madras in 2009, actually, I came from a physics background and joined an engineering department. What I had access to is a 10 gig BERT, SOA, a DFB, and a tunable laser, an optical spectrum analyzer, and a fusion splicer. This is all what I had access to. That was a time when, of course, it was the beginning of my career, and the climate in India was not that conducive for big funding, at least in fiber optic communication, so struggling for the seed funding. The only way I could survive was because of a few very highly supportive colleagues who opened up their labs for me and showed by example, of course, of what to do and what not to do also. And what really made a difference was the collaborations I could set up. I was lucky enough to get a travel grant to Dublin City University, Ireland, and hosted by Liam Barry, who's popular in the fiber optic circles. And that started a series of collaborations, and that's how I actually started my career. And what do I do right now? Try to, in the area of communication, like the rest of the world, try to see if we can approach or scale the Shannon limit. So either by doing some kind of pulse shaping and DSP to see if we can increase the capacity of legacy networks, especially focusing networks in India. Expand the carrier frequency using SOAs or any other wideband amplifier. So we have done some work in terms of improving the performance of SOAs for coherent communication as SOAs as amplifiers, methods to get rid of distortions. More multiplexing, space division multiplexing, mode division multiplexing for improving the nonlinear limit and scale capacities. And most importantly, this is where I started my work on with photonic processing. Now we have moved on from digital communication to analog communication for photonic processing. So from 2010, it is only in 2016 that I got the first big funding where we could establish a high-speed optical testbed. This is no more high speed in today's standards, but we still work with this DAC, which is 63 gigasamples per second, and ADC with 80 gigasamples per second. Moving on, we started demonstrating 400 gig WDM, few mode transmission, 1 tera again with the comb source, again increasing the capacity with few mode fibers, and so on and so forth. So these are some of the key achievements. We did wavelength conversion with OOK back in 2010. Then we started at Dublin, we started our work with coherent communication, again wavelength conversion work. Then we moved with industry collaboration to do multi-channel coherent, and this is the testbed that was funded by the Office of Principal Scientific Advisor of Government of India. Then we demonstrated mode division multiplexing, all banking on the same testbed, and 1 terabit super channel kind of experiments with optical frequency combs. Currently, we are also attempting using these classical transmission equipments. Can we demonstrate a flavor of QKD by name continuous variable QKD? In terms of photonic signal processing, we started with fiber lasers because I also work in the area of fiber lasers. So we started using injection locking in fiber lasers for clock recovery for coherent data. We moved on to use nonlinear SOAs, and we hit upon this new concept of backscattering four-way mixing in nonlinear SOAs, and then we moved on to use the nonlinear SOAs for dispersion and nonlinearity compensation, SOAs for phase quantization, SOAs for distortion-free amplification. And as you can see, a lot of these work, some of these work were done in collaboration. For example, this one was done with AIST, Japan. We had carried out some of these experiments in DCU, this was in IIT Madras, and so on. In the domain of microwave photonics, we started with radio over fiber targeted towards CRAN front haul back in 2015. This is done in collaboration again with DCU and our own 5G testbed. And currently we are working with our own 5G testbed for transport of 26 gigahertz and try to identify the optimal split in CRAN to make the remote radio head lighter. In collaboration with an industry, we have demonstrated photonic ADC, and currently we are experimenting with different versions of photonic ADC for different applications like instantaneous frequency measurement, sub-Nyquist sampling, and so on. There was funding in the area of 2-micron laser development, and so I dabbled with that, continuing to do that, where initially we did pulse lasers for infrared countermeasures. Currently this is being modified for medical applications. So this is an example of a packaged laser that we have developed. Mode lock lasers also for medical applications. And with the LIGO India, there is an interest with 2-micron, and so we are trying to make our own attempts to reduce the line widths of the lasers and measure the phase noise correctly. All this work has been possible only with the hard work of all my students. Some of them are past students, and they are all distributed in different parts of the world, and I am really proud to have them interacted with them. I'm a big fan of collaboration, and we currently have collaboration with Dublin City University through a program called Vajra, which is actually funded by the Government of India. Government of India also has another funding program called Spark. It is for promotion of research and collaboration. So we have two Spark projects, one with Southampton and UTS for fiber lasers, and another one with AIST, Sydney, Melbourne, and Rochester for photonic signal processing, digital and analog communication. For photonic ADCs, we get funded or we collaborate with an industry, and for few mode and space division multiplexing, we collaborate with a fiber manufacturer. There's some collaboration we had with Russia, and currently with South Africa and also with Russia for communication with structured light and for dispersion oscillating fibers. So here are my funding agencies, and without their funding, none of this work could have happened. And with this I conclude, and thank you. Here are some pictures from our own campus. So I welcome you to India and to IIT Madras. Thank you.